Do you not understand that sometimes people say things?
Hey,
Sean, I'm finally unmuted. I can answer you now. I know you directed that question to me. Chemo's had me muted this whole fucking time, dude.
I didn't see you in the
thinks
chat. My
he's
bad.
fucking smart. Yeah. So I never said that it replaced gravity. What I did say though was that they're using Maxwell's equations on the nano scale for electrostatics, and I left a link.
Down there. I see what you're saying. I see. Okay.
All molecular and intermolecular attractive forces are electrostatic in nature.
No, they're not.
The problem. The problem
they are.
Why are you calling WITSIT? Why are you saying it like that?
Yeah.
Because
they literally, even with our old explanations of an atom, most of the space is magnetism in the middle.
Okay, now, Grim, just because Whitson's attaching himself to your argument,
why are you saying it like that, Sean?
Because Chemo, I'm in the middle of something. Shut the fuck up.
Stop derailing, Chemo. That's literally all you ever do is derail.
Yeah, dude, just shut up. Fuck.
You guys are going to run away from this. That's ironic. You're talking about derailing.
No, I'm keeping it right at what we were talking about.
We'll hear.
On this local scale, Grim.
I'm actually supporting you.
Does Newtonian work?
I'm talking about this one guy. He's going to run away.
No, but that's the thing.
I don't even know.
But what I said about your
Newtonian
attaching to his, what he's saying is exactly what you're doing, Whitson. And
let me explain this to you. Let me explain it to you, okay? So if you look at Coulomb's law, it was hijacked, and then with the presupposition of Newtonian mechanics reverse engineered based on the local scale, you've now not accounted for the electrostatics, and you've made claims as if Newtonian mechanics, assuming gravity, has been validated by looking at the phenomena on the local scale, which is where it was actually originally derived from, and you never accounted for electrostatics.
Now, here's the question.
He's got a point there, because we didn't know that we could apply that without changing the tensor.
But here's the problem, Whitson. Wasn't that presupposed as well?
Electrostatics?
Yes.
No, you can verify it.
You can verify.
Well, it was initially, though. It was presupposed, and then it was.
It had to have been. It's the same.
But here's the problem. Here's the problem. You made a presupposition ignoring what we know. Listen, let me respond.
No,
you made a presupposition
ignoring. What I'm saying is there's no problem with making a presupposition.
Yeah, there is a problem when you make a presupposition.
As long as you verify it, it's a hypothesis.
It's a problem when you make the presupposition disregarding what has been verified and is no longer a presupposition.
That's not true.
And your presupposition requires you disregarding the verifiable phenomenon.
In order for you not to presuppose a thing, that means that in science we would have to stumble on shit all the time and accidentally come across stuff all the time instead of thinking our way to this thing.
No, you don't understand. What actually happened was, when we know electrostatics is a real thing. Coulomb's law, all molecular and intermolecular attractive forces are electrostatic in nature, 100% provable, undebatable.
Yeah, we know now.
Now, here's the point.
Listen,
here's the point. The reason that they couldn't use it, the reason they couldn't use it is because you can't apply that to a quote-unquote solar system scale, because electrostatics would not result in planetary movement or orbital trajectories because it would be too weak. So what they did was exclude that as a possibility, although already verified, and then they came up with an additional attempt of a presupposed narrative to explain the planetary movement.
I totally agree with that.
What was before that then, Whitson?
Listen, I totally agree with
how did they know electrostatic before?
That's irrelevant.
No, it's not. It's only irrelevant. If it's only irrelevant if you don't want your argument to be scrutinized the way you're scrutinizing everything else.
It's about interpretation, Sean.
No, we can verify.
I get its interpretation, but the problem is that when you say that they figured out one way, and then because they figured out an easier way or a better way of explaining something, the first one doesn't work, and that's not how this works.
That's not what I said. That's not what I said. It's not a better way, right? See, if you were honest, you would say, okay, well, what we know is here's electrostatics, and this couldn't explain what we're trying to theoretically explain and propose.
I'm not saying
Stop interrupting me, dude.
Oh, so come on, you're making it into a poo show.
You're trying to see it. You're trying to.
You're saying everything is one force.
Just talking, dude. Don't do that.
See, Sean, what you do, you interrupt, and then this gamma interrupts, and then another gamma interrupts.
God, hang on. I want to hear what Whitson was saying. I apologize.
Okay, so we're trying to theoretically propose the idea that the Earth is a sphere inside of a heliocentric solar system. Now, we want to explain how that could happen. Now, we have electrostatics. We know that's real. We verified it. It's provable.
How? Where did we get that from? But where did we get that from, though?
I'm going to finish. But it doesn't explain, it cannot explain the planetary movement in the heliocentric solar system. So what they did was, as opposed to being intellectually honest and say, well, maybe it's not a sphere in a planetary system that's revolving.
Why?
They didn't even entertain that possibility. They threw it out, and they came up with a theory excluding the verifiable phenomena of electrostatics to explain how the Earth could be a ball in a solar system.
It wasn't thrown out. We still study it. We have a greater and greater understanding as time goes on. But you stated that we verified electrostatic had worked. Where did we discover this? When did it become something?
I don't know the year it became something.
Okay,
it's irrelevant.
Why doesn't it explain the orbital paths of the planets?
Because there aren't orbital passive planets.
Okay, so then if something else was figured out to explain the phenomenon that was happening, and it works when we test it and do experiments, then why is that not verified?
You did it. First of all, it's not to explain something that's happening. That's you presupposing the planetary scale that is in contention. It doesn't have. That's against circular logic.
Again, presupposing is fine as long as you're going for the verification of it as well, which is what Newtonian has done. Which is
how they do it. How they do it?
By running tests and experiments over and over and over and over.
Like what?
Really? Are we going to go through this?
Name one.
Cavendish.
Cavendish?
Yeah, that's one.
Cavendish. So your claim is Cavendish proved Newtonian mechanics.
Yeah, mass attracts mass.
Wow. Okay. So gravity is no longer an intrinsic property of matter, mass attracting mass. That's
okay.
That's
again,
antiquated.
that's just what you're doing right now is telling me that Chemo, shut up.
But you're interrupting the answer.
Yeah, you know what? Chemo, you're interrupting. Shut up.
What's the point of you asking questions if you're going to interrupt the answer?
Shut up.
Well, I'm monitoring your interruptions. Go on.
So what you're telling me is that general relativity was then explained, and that threw out Newtonian. But you understand that to come up with special relativity, to come up with general relativity, there are certain aspects of it that have to look at it as a mass attracting mass in some situations. Now, what you're saying is electrostatic works in up to a certain scale. Well, we're telling you that Newtonian works to a certain scale. We're telling you that general relativity works to a certain scale. And now that we're all in the endeavor of quantum, there are certain things that work in that scale. Now, you asking for a unified theory of all these things is far-fetched for anybody, even on your side.
No, it's realistic if what you're trying to explain is actual reality, right? So this is what actually happened. Electrostatics explains
that was a disagreement. Can we pull the pen on that real quick? I don't mean to interrupt you, but how does everybody feel about that? Do we think that that's ridiculous or not? I'm with WITSIT. Anybody else?
What part of it is ridiculous?
It's not that you kind of saying, well, we don't expect it to be, but it's like we all want it, so shouldn't we expect it to be?
Wait. I didn't say anything about what we should expect it to be.
You said it was ridiculous if I expect a universal.
Yeah, 100%. Yeah, because have a universal.
Okay, we disagree with you. This is two people that disagree.
Okay. Now, to have a universal theory of everything, you understand that everything needs to be understood completely. We need to know all the particles. Okay, what would make a universal?
Because you're just explaining a certain aspect of a phenomena, right? So you don't have to know everything. But again, I'm going to explain it. Okay, electrostatics.
Before you,
and it was his term. But
the thing is we were talking about a universal theory of everything, not an understanding of one thing. That means everything works. Everything. You've already stated that electrostatic doesn't work in certain scales.
No, it works everywhere. So here's the deal. It works everywhere, but it can't explain how planets revolve. Well, that's a good thing because they don't. And you can't even intellectually be honest about it. So electrostatics works on the local scale. You just presupposing there are planets, so you say electrostatics doesn't work because you have to reify your belief system. So
I'm not presupposing that.
Yes, you are. Electrostatics works.
No, I'm not at all.
Yeah, you are. Electrostatics works on the local scale.
How I verified that then?
That the Earth's a ball in a planetary system? Yeah, I'd love to know.
Yeah. Okay. There's plenty of evidence. There's plenty of observations. There's plenty of experiments. There's plenty of tests. There's plenty of plenty of explorations into space. There's all these things that you can compile with evidence. Now, to say that they're all fake and then presuppose your idea of what we live on is kind of far-fetched. Where is this exploration to high enough that we've seen all of flat Earth? Where are these maps? Where
are you done, man?
Work?
You're scared to hear me say that.
You can't just monologue, ask a question, and interrupt it.
Yes, I can. Shut up, Kimo. I don't want to hear
can't.
Okay, so I'm going to explain it, and don't interrupt me this time, because I know you're scared of me explaining it. So electrostatics works on the local scale, always to this day, till the end of time. Works to explain everything on the Earth. Okay? Perfectly.
Okay, on a local scale, you said, right?
Perfectly
you said
on
a
the Earth.
Scale, right?
Well, but we have a difference in definition of local scale, because
in the verifiable realm, which it might be a better way to categorize.
There you go. Well, in the verifiable realm of the local scale. When I say local scale, you guys will extend that into fairy tales about a solar system. Okay, so on the Earth, electrostatics works to explain all phenomena perfectly. It's verifiable. It can be proven 100%. Now, when we extend it into trying to presuppose that there's a planet in a planetary system, it doesn't work. So what you did, you came up with Newtonian mechanics, and you said, well, it's actually scalar, and that when it gets much bigger out in this presupposed solar system with presupposed masses, right, then there's something else that overtakes electrostatics, and it becomes the prominent vector, or what results in vectors, the prominent force that results in vectors, right? Because electrostatics doesn't work. So you had to throw out what we know to be true and always work on the Earth to try to come up with some hypothetical way to explain how the Earth even could be a ball in a solar system. And that's where you got Newtonian mechanics. But then when you extend it beyond the solar system, it doesn't work. So then you got the theory of relativity. But then it doesn't work on that scale either. It's off by 95% dark matter and dark energy. So you guys are just running around trying to explain something that can't be explained.
Well, why are we throwing out
when you say that, okay, then when they did this replacing of, did they stop saying electrostatic was a thing?
They said that it just effectively disappears out into space.
No. We're staying on
They did
Earth.
do that, though. They said that there aren't any long-range electromagnetic effects in space. No long-range shit. Nothing from the sun to the planets.
Okay.
Because there has to be. Let me. Wait. Great point. Wait. Let's address it. I want you guys to know it. It's because it has to be a vacuum.
I didn't.
No.
Okay.
But address
no, I didn't interrupt you.
Because it has to be a vacuum. Because if the sky's not a vacuum, the Earth can't be the heliocentric model you think it is. It can't be.
So, do Newtonian mechanics, do they work on Earth? When we do the tests, do they work here on the surface of Earth?
Well, it just hijacked Coulomb's law.
No, but does it work though?
Yeah, Coulomb's law works. Yeah.
No. So Newtonian mechanics does work on
further than
surface
that.
of Earth.
It goes deeper than that, though. But
it hijacked Coulomb's law and then threw in a G.
But I'm literally just asking a simple question. Newtonian mechanics works on the surface of Earth, correct?
No, it just
electrostatic works. So does Newtonian mechanics.
Do you know what the difference is? You can actually prove one of them.
Okay.
One of them is provable, and the other one is not.
Okay, what would be the source of electrostatic?
Newton said himself that he doesn't know the reason why. He just knows it does.
Oh no! To this day, we don't know why.
He actually said for gravity to act in vast distances of a vacuum on innate root matter is a piece of great absurdity that no man with common
better yet, which test and experiment that verifies these things is wrong.
Acceleration is measurable, but it doesn't necessarily work.
The source of gravity we don't know. That's clear. But which test and experiment that is done to show that Newtonian mechanics works is wrong.
Which one of them excludes for the variable of electrostatics?
Electrostatics explain everything, Kimo.
Name one.
Well, listen.
Strong
when you start talking about the electrostatics,
gravitation
being
separate from the electrostatics, there are 4 forces in physics. You only think
in theory they're separate. In theory,
exactly.
They're separate,
in theory, so electrostatics can be proven, and then Newtonian is just a theory to explain how the Earth's a ball.
Wait a minute, hold on.
They're both theories.
WITSIT. How do you hold everything together inside the nucleus of a molecule? They're all positively charged. The strong force does that. That's not electrostatic.
The theory says they're all positively charged, right? But they don't necessarily. See, there's also a structured
NASA doesn't
atom
care.
model.
He just wants to talk. NASA just wants to talk.
All molecular and intermolecular attractive forces are electrostatic.
Is NASA familiar with the SAM model, right? The structured atom model, right? Where there are no neutrons. They're just a balanced number of protons and electrons.
all molecular
Look that
and
up.
intermolecular
There's a SAM
attractive
model
forces.
where it is basically it is just the electrostatic forces. There is
And
not
at small
there's not
scales,
only
all I
one
can
model of
measure
the
is
atom, guys. There's a SAM model that it shows that it gives better examples actually for the structuring of these molecules and stuff, and how they would divide, and how their covalent bonds would work and everything. Like, look that shit up.
The subatomic scale is being redefined in front of your own eyes within your own paradigm, and you guys are ignoring it.
It's happening right now, guys. The SAM model is being taken seriously now. It's showing, it's predicting the ability for fusion and fission. It's doing all this kind of stuff.
SAM is SAM, structured atomic model.
Grim, does that explain the shape of our Earth or anything like that? Or it
explains you don't have an actual provable mechanism to explain how the Earth's.
I was asking Grim Whitson. Thank you.
It's
well, no, but you can kind of deduce, right? Yeah, you can kind of deduce from that, though, that there is forces there that do create spheres on all scales.
Oh my gosh!
So even electrostatic create it, even that
more likely to be a sphere electrostatic than
electrostatics doesn't work for your heliocentric model, though.
Again. You see how Grim tried to give his best explanation, but you just rant out. It doesn't work. Explain to me how
objectively. Okay, I already did 5 times. Take your crayons out, buddy. Okay, so electrostatics is too weak. Well, you don't listen. Electrostatics is too weak.
I just don't listen to people that yell for no damn reason.
Okay, well then listen. I'll whisper it to you. You can pull out your crayons.
Thank you.
So electrostatics is too weak to make the Earth revolve around in a solar system with spheres. Objectively, it doesn't work for your model.
Is that true, Grim?
Right. No. Only if we assume that there's no plasmas, there's no electric currents, there's nothing else going on out there. And we don't assume that anymore. We used to assume that.
Graham, can I ask you a question? Do you agree? Do you not understand that the heliocentric model requires a vacuum? Do you not understand that?
No, I don't.
That's not the.
Well, now you get why it has been stifled in mainstream science. Maybe now you're getting why.
Wait, we're talking.
No, I don't understand the actual significance.
The significance is either we are going to drop this model where spheres are revolving by some sort of most likely electrostatic force, or we're going to try to prop up this sphere, ball, orbit thing with some sort of magical gravity force that is unproven and unfalsifiable. We're at a real crossroads here. I suggest that we drop the spheres being pulled by this mystical gravity force and go electric with, at best, lights up in the sky with maybe a sun and moon. On a local scale.
Crossroad for science.
Let's just forget the whole Cavendish experiment. Forget a century of gravity. How long has gravity been around now?
Look at this guy. The comments like, someone came up with a theory a long time ago. Look how long ago someone came up with a theory that makes it real.
Well, it does.
I mean, again, we'll go into that in those rounds again. Grim, this is because you're not a real globe earther. Now, Wiggles, is your mic working?
Hello?
What's going on, Wiggles? You still on the globe side?
I came up. Oh, of course, yes.
So, let's get into it. How do we know we're on a spinning ball flying through space?
We have pictures.
Hold on, Page. Let Wiggles get into this a little bit.
Well, flat earthers require that you prove everything yourself and ignore the rest of science. So what I've done myself is just prove that the Earth is not flat. That's as far as I've gotten, really.
No, you haven't.
Yes, I have.
How'd you do that? Looking at the sky?
No, looking at bodies of water obstructing distant objects.
Oh, so does the obstruction stay consistent or does it fluctuate?
Well, once the object is far enough away, then you consistently get obstruction every single time.
So it gets obstructed at the exact same distance every time?
Doesn't have to, WITSIT.
Hey, why are you jumping in?
You guys ever heard of the
Come
total
on, for
internal
goodness
reflection
sakes.
of light?
Have you never heard of a conversation before? Is it that difficult to hear someone express their opinion?
Why aren't you saying that to Don?
Challenge him with
Come on, Don,
internal,
work with me here. Let
total
Wiggles.
internal
Let him get
reflection.
through at least 2 minutes. He didn't even get a few words out.
Okay, so WITSIT.
Go on, Wiggles.
Yes, so light does bend around, like, the curve of the Earth, which explains why
Can you prove
the
that?
obstruction starts at different Well, yes, I can prove that light bends down in several ways. Yes.
Wait, so
Can
you
you
agree
prove
the
it's
obstruction's not consistent?
No.
What if it's at a distance where it's all of it can't continue on and make it to us?
So WITSIT, I've done my own observations with this, and
Yeah, so have I.
I picked a 130 meter tall island 40 miles away, and it was obstructed when I looked from the beach every single time. Every single time it was obstructed.
Was it obstructed at the same place?
It was. What do you mean by the same place?
Well, yeah, is the obstruction at the same place?
Well, it was always obstructed. I don't know.
I think
Is there the same amount obstructed every time?
Yeah, the whole thing obstructed every single time.
And so it's identical every time you made your observation.
Yeah, basically, yeah.
You're a liar.
He's talking.
Why am I a liar? You can.
He's talking about.
I do it all the time. I make
about
observations all the time. You're lying.
conditions.
You don't observe shit.
He's talking about He's talking about atmospheric conditions that affect observations. Is what he's talking about.
Oh.
Well, whenever you come out and you say, look, there's a physical obstruction that shows the Earth's a ball, and then I say, okay, so you're saying this is physical. So is it moving and changing? Yeah, it's changing, but I know it's actually sitting still and physical. Just believe me. That's your actual argument.
Light bends around the curve. You understand that, WITSIT.
If I presuppose that there's a curve, so first of all, what you have to do is you have to invoke a curvature of the atmosphere, which is stupid. Gases have no inherent shape. There is no curving gas. You have to invoke that. Then you have to say that.
Presupposition.
Yes, it is. It's a presupposition. Gases. That's antithetical.
No, it's a presupposition.
You interrupt every time.
In your argument,
Sean,
that
what's the
people
problem
have
here?
verified it. I just wanted to clarify that it's not a presupposition.
Yeah, it is. So it's antithetical to the
Steel
behavior
City,
of
you've got
gas.
a hot mic, by the way. Steel City, so mute yourself.
It's antithetical to the behavior of gas. Gases have no inherent shape. You have to presuppose an atmosphere with a curvature within the atmosphere itself. The gases are curving. And then you have to presuppose that the Earth's a sphere with a certain radius. Then you have to presuppose that light's magically bending at the perfect rate needed whenever you don't have the observation that you want.
Atmospheric gradient has
Well, the Earth
also
must
been
be a ball.
verified.
No, it hasn't.
Yeah.
Wait, so you can't go buy a barometer?
A barometer verify the radius of the Earth?
Okay, so WITSIT, I did not presuppose anything. I just I took the hypothesis Earth is flat and I rejected it. That's all I did.
Oh, did you ever? Okay, so here's the problem. Whenever you try to test out the Earth's flat, and you go out and you get really clear conditions, and you can see way further than you're supposed to on a globe, you will instantaneously say, "Oh, well, it's just bending around the curve. It's just actually bending around."
Show me
Okay,
those.
we're not talking about globes now. We're talking about a flat Earth.
Yeah, that's my point. On a flat Earth, what would happen is you would see further or not as far based on the conditions. When it's clear outside, you can see further. So when you go out on a clear day, you can see further. Like, oh, I can see those mountains now. I can see that island now. I do it all the time. Okay? When it's clear, you can see further. And on those days that we see further and see exactly what's there, where it's at, right? And we can see further, you guys say, well, even though it's clear, it has the most refractive effects on the clearest days. And actually, that's not what you're really seeing. It's bending around the ball. That's what you say.
No, like on days when it is clear enough to see that distant island, like I don't see it, and the only explanation is the ocean is blocking it. That's the only explanation.
No,
on a clear day, yes. Listen, on a clear day, there are mountains you still don't see the base of them. You don't see 80 feet of cargo ship that's missing on a clear day. Because I got observations that I took with flat earthers on a clear day with 80 foot of obstruction on a ship. So what would be explanation for that? It wasn't clear enough.
Oh yeah, or I guarantee you that you can make observations where there's not 80 feet of obstruction. Guaranteed, 100%.
Not, you're right. Because at no point does that ship ever, in that distance, ever do you see the whole ship. There's always 80 feet of obstruction, or it's hazy, but guess what? You never see 80 feet of it. And that would happen on a flat Earth on a clear day, wouldn't it?
No, see, there's no such thing as a perfectly clear day, but when it's clear, you can see further. So are you saying that 80 feet is the curvature? Are you saying that 80 feet is the curvature?
Yes, it is due to curvature, yes.
Okay, so when you see the 80 feet of obstruction, you're seeing the physical curvature of the Earth.
I'm seeing the physical obstruction from the body of water due to the curvature.
Okay, so if I come back and there's only 70 feet of obstruction, did the curvature shrink?
No, this is on a clear day.
You can't answer the question, can you? If I go back
on a clear,
and it's only 70
okay,
feet,
I'm sorry. On a clear, we're assuming clear day, perfect conditions. No, you're not going to see 70 feet. You're not going to see 60 feet. You're not going to see 40 feet at the same distance. No.
So if you ever see less than 80, it debunks the globe?
At that, from a certain distance, absolutely. On a perfectly clear day, as we are talking, yes.
There's no such thing as a perfectly clear day. I thought you said you made observations.
Dude, we just got done saying that's what we were we were going to presuppose of this experiment, right? Because
This
I can tell
isn't
you
an
right
experiment.
now, you're not
Okay.
Okay. So if you see less of that 80 feet and the conditions aren't a clear day, then it is some refractive quality. And how do we know that? Because we understand how light works. And it is explained when we calculate all the data that's in these observations over and over again. It is explained by refractive conditions.
Watch this. Watch this, dude.
Okay.
So when it's clear outside, can you see further?
Yes, obviously.
Okay, so whenever it's clear outside and I can see a lighthouse from 20 miles away, but whenever it's not clear outside, I can't see the lighthouse. What's the cause of the difference?
On a clear day, I want to see the 20 feet, and then I want to see the extra whatever hundreds of feet that it's tall that you're still not seeing.
Hey, whenever it's clear outside, you can see further.
Okay, so at a certain distance, you're still going to see something if it's tall enough. That's pretty obvious. Now,
What's pretty obvious
is if on that clear day and you can see that lighthouse on a clear day, then you should be able to see the whole lighthouse on a clear day, not just
That's wrong. That's not true, because even on a clear day, there's still some atmosphere, right? So you never can just remove the atmosphere, right? So you have angular size change with distance, angular resolution. There's always some atmosphere. But when it gets clear, when it's clearer, not perfectly clear. I don't know why Globers make these ridiculous leaps, illogical nonsense. But say that it's clearer, that's when you can see further. I do it all the time. And when it's clear outside, you can zoom in and you can see the lighthouse, you can see the island, you can see the building.
You can't see the whole thing. I bet you can't see the whole thing.
And so if we do, okay, what about whenever I can see the skyline?
And you brought up angular size.
You're not supposed to see the whole thing, dude.
When you're talking angular size, you are not talking about any obstruction to any side. You are talking about its angular size shrinking. So that object, that full lighthouse that you're talking about, you would still see it.
It's not either or, dude. It's both of them are at play. So well, you're just honing in on angular size. I said there's angular size.
Then where does the obstruction come from?
There's angular size change with distance, and there's an atmosphere. You never get a perfectly clear day that doesn't exist.
Come from
the atmosphere.
If you can see the top 20 feet of a lighthouse, the atmosphere to the bottom of it does not change that drastically.
All right, let's do this. If I go out and I look at the lighthouse and say the lighthouse is 50 feet tall, and I go out and I make the observation, and it's one day I can only see the top 10 feet of the lighthouse. Okay, then I go back the next day and I can see damn near all the way to the bottom. I can see damn near all the way to the bottom of the lighthouse, right?
What's the temperature of the day?
No, that's not. That's non sequitur to my point. Whenever you're going to answer my question, man.
Because if you're going to verify what your observation, these are the type of things that they actually take into account to verify what they're seeing. So
this is a hypothetical that you won't be able to answer. So whenever you can only see the top 10 feet of the lighthouse, and I go back the next day and I can see damn near all the way to the bottom. So whenever I can only see the top 10 feet.
What's the difference in the day?
Hey, whenever I could just see the top 10 feet of the lighthouse, was it because of the curvature of the Earth? Yes or no?
Depends on the time of the day.
Yes or no?
Depends on the condition. I'm telling you right now. This is why I was saying what I said, because it would matter if it was a cloudy day, foggy day, clear skies, sun above you. I mean, there are different variables that change. So having the data for these things is very important in verifying. But seeing how you clearly don't have any of that data, how did you verify that you were seeing something that was on a curve?
Oh yeah, this is just
okay. How about this? How about I put that ship that has 80 feet missing on a clear day, a video and screenshots in the chat, and then we discuss the temperature, the time of day, the temperature of the water, everything. Because I actually have that. That's how I verified it. Now you show me your data that verified I'm wrong.
Okay, so once again, whenever it looks like there's more obstruction, It isn't because of the curvature of the Earth. The curvature of the Earth isn't changing. It can't. It doesn't breathe in and out. Okay, so the apparent obstruction fluctuates based on the atmospheric conditions daily, objectively. Now, you guys make an additional claim that although we know that's the case and that's how it would work on a flat Earth, it's actually a curvature there that you can't isolate.
No one explains that's how it will work on a flat Earth. It's
Yes,
how
it
we
is.
explain it works on a globe, because all the data that I just ran off and listed matters in the observation. And again, I said it. That's how I verified my observations. Where's the data that verified your observations? Because you're telling me about these hypothetical things, but I want to know where you verified it at.
Okay, so what you're scared to answer the question, and this would be very telling to
No,
the
I
audience.
answered the question. I
No, you
answered the
didn't.
question.
No,
because
you
it,
didn't.
It matters. Okay, I'll say it again. It matters on the temperature of the day. It matters the conditions of the day. Fog, cloudy skies, clear day.
We
time
know
of day
that.
where the sun. No, I'm talking. And no, you don't know that because
Yeah, I
you
do.
haven't verified it.
Yeah, I do. I'm
How have
smarter than
verified
you.
it?
So, hey,
Okay,
here's the deal.
let's see. Let's go over your observations and the data.
No, no,
you
no, no,
collected
no,
in
no.
it.
You're going to answer the
No,
question. Is
you
the
don't want to do
obstruction,
that?
hey, whenever there's 80 feet missing of the ship, is that the curvature of the Earth, yes or no?
Due to curvature of the Earth and the physical body of water, yes.
Okay,
Because
so
there are show me
no,
an
I'm asking a
atmospheric
question.
show me an atmospheric condition that would obstruct that ship 80 feet
Okay,
and
so
not have any distortion.
Okay, so you said that it was a curvature of the Earth. So then when 80 feet is missing of the ship, right, and you say it's the curvature of the Earth, you're saying that we're seeing the physical, actual location of Earth's curve, right?
No.
Oh,
That
so we're
starts at
not
your
seeing the
feet.
curvature of the Earth.
That starts at your feet to the observation that you're making.
So we're not
To
seeing
the
the curvature of the
reference
Earth.
Oh no, it's due to the curvature of the Earth. Absolutely, due to it's a body of water. Yes.
So, but we're not seeing the curvature of the Earth, though.
Yeah, but
Seeing
are
the
you
effect
not,
of the curvature. Of the
Yeah, are you not hearing me?
Oh,
You are
so if
you are observing
presuppose that there's a curvature there.
due to the body of water that is obstructing it due to the curvature of the Earth.
No, see, you're
I can't
just
say it
saying
any more
that.
clear.
Yeah, but you're just
No,
saying
no,
that.
no. I verified it. I've already
No,
verified
you
it.
didn't
and I've
verify
already-
shit.
Okay. Would you
Okay,
like to
the
go
only way-
over? Would you like to go over the observation that
I would
I'm
like for you to
explaining
stop
to you?
interrupting. I'll
Because
let you
you're
finish and
going,
interrupt me every
you're
time.
going over a hypothetical, and I'm talking about a real observation.
Yeah, I'm talking about how your interpretation of the observation is really stupid as hell.
No. Because I have the
Anyway, I'm
data.
gonna just talk
Because
through
I
you
have the
then, because
data.
you're not gonna keep
It's
interrupting
not
me,
that.
dude.
It's me verifying it.
Stop interrupting me, dude. I'll let you finish,
Stop.
and you're gonna let me
Stop,
finish.
stop
Okay.
with the BS arguments.
Okay, so you can't claim that it's a physical obstruction of Earth curvature and then simultaneously claim that it's not the physical curvature. That's dumb. Okay,
What
so
are you
you're
talking about?
presupposing. I get it. You're lost. I get it. That's why you're
So
over.
basically, you weren't listening. So I'll say it again. The curvature starts at your feet.
I'm not. I want trying to
and
hear you say it
to the
again.
end of your reference to whatever you've referenced. Now, the physical curvature that you keep saying starts at your feet. The reason an object is missing, is obstructed by 80 feet, is due to a physical body of water there that is causing obstruction due to curvature. So you
Okay, you're
don't
just
have
saying
to
that.
lie. No. It's been verified. How has
No,
it
it
been
hasn't.
verified? Yeah, I made the observation. I recorded the data that's necessary to verify what I was looking at, which takes into account atmospheric conditions, which takes into account the physical body of water, the physical ship that is physically missing 80 feet. Now, if you want to talk about atmospheric conditions that could play a part in that observation, go ahead. But I verified it. I have the data.
You didn't verify
You can
shit.
bullshit. Yes, I have. You don't verify. How do you verify stuff then?
Well, then
Just
how about you
saying
shut the fuck up and stop interrupting me, bitch?
I've asked you 3 times, Whitson, for your verification of your.
You interrupt me every time.
Theoretical.
Are you done interrupting me like a 5-year-old?
Okay. Yeah. Now say you're going to verify and say something else. Go ahead.
Okay, so what you need to do is physically measure the curvature for starters. Now, for you to verify that it's a physical obstruction, you can't just presuppose it's there, see a fluctuation in obstruction based on atmosphere and say, well, yeah, we're not seeing the actual physical curvature, but I promise it's there. That's dumb. So, no, the Earth's not breathing in and out. The Earth's not breathing in and out. You can't respond with specificity. You're
I'm
like a
not
5-year-old.
hearing how you verified anything, and that's what you said you were going to do.
I'm asking you to verify that it's curvature.
I took all the data. You want to hear the list of data that I took?
I want you to acknowledge that you can't simultaneously claim that it's physical curvature and that it's not the physical curvature at the same time.
No. The curvature is measurable, so therefore that's been verified as well.
How do you measure the curvature?
You want a simple way, or do you want the technical way? Which one?
I want the way that actually did it.
Oh, how? Okay. First, you measure the elevation over a distance. Create a mean line. Then you measure the angle to whatever you have in the distance as your reference point. And you will notice that that angle does not stay at 0. It will usually drop significantly. And if you're looking at something that is 1,000 feet above you, and you're looking at it down at 2%, there's a problem there. That means there is physical curvature.
No, it doesn't.
That means
yeah,
it does. That's exactly what that means. It does.
Does the angle fluctuate?
No.
Yes, it does.
No, the angle does not.
It objectively does.
Oh, wait. Over everywhere, or that one observation?
Well, we're making numerous observations.
Oh, okay. Yeah. No. Okay. No. Then no, it doesn't. No.
Yes, it does.
No, it changes.
You don't even know your own religion.
It doesn't fluctuate, because if you're saying fluctuate, you're saying does each observation fluctuate? And no.
Stop it and make us graphic cunt.
This dude just said that it changes, not fluctuates.
Depending on your that means if you go 100 miles in one direction and you do the same thing to a mountain that's exactly 1,000 feet, it may be different due to the fact that we don't live on a perfect surface of a ball.
Do you know what fluctuate means?
That's why you would have to. Yes, that means you would like breathe. It means it would change, and it doesn't.
Yes, it does.
1,000.
So
no. Oh,
yes,
so you're telling me a mountain 1,000 foot above your elevation is 1,200 feet above your elevation at some other point?
No, you're so lost. So whenever you make these observations,
the
angle. Stop, interrupt. The angle fluctuates. It goes up and down. It changes.
Oh, how? So the elevation changes, you're saying?
No. Just the perception.
Do you understand? No. That's why we use tools.
You don't even understand your own religion.
It's not a religion, and we understand that we use tools to
use optics. You clown show.
Yeah. And you're telling me they fluctuate. So so you're telling me that the physical Earth fluctuates because you're not. It's literally not how you claim.
You're claiming that the Earth physically fluctuates. You just dismantled yourself. No, I'm saying that it changes based on atmosphere over a flat Earth. You're claiming this is proof of a physical curvature.
How did you make up that argument, Whitson? How did you make that argument? Because I just told you it didn't. You just said to someone chimed in a second ago. This guy says it doesn't. So how's my argument suddenly now? That you can go back 30 seconds in this conversation and hear it.
Yeah, you're getting dismantled.
And you still haven't verified how you know any of these things. So all you're doing is presupposing everything you're saying.
Run away, bro. Oh, that's ironic. Self-project much. So whenever you look out at it, it constantly fluctuates. And then you take a mean, you take an average, because it constantly moves up and down. Right? And so just like you said, no, but it's objectively what happens, though.
No, it's not.
No.
Okay, cite it. Cite it.
No, I'm just explaining how you're wrong.
Cite it.
So, do you have a little bit of brain? With your huge intelligence, you have expressions like
you. So whenever you invoke geodetic surveying, there's a mean, there's a weighted mean, and then we throw out things that are too great.
I did. That's elevation. We're not talking about the elevation. We're talking about
You did invoke elevation.
Talking about a mean line set up to your observation. It has nothing. It has nothing to do with the actual elevation. Sorry. That's how I know you don't understand.
You're so lost.
No, you don't understand what you're saying.
Does everyone think this guy's winning?
Not at all.
Oh, not winning. It's just showing how
you guys are
destroying you.
Destroying me? Wait,
fucking stupid.
Let me ask
Shut up already.
Let me ask all. So does everyone agree with him that it doesn't fluctuate? Yes or no? Does everyone in the room agree with him? Does everyone in the room? I'm just gonna keep talking. You're not gonna get to interrupt me. Does everyone in the room agree with him?
Let's ask Wiggles directly. Wiggles, does this horizon fluctuate?
Why?
Yes, the horizon changes in like the angle you have to look down to see the horizon will change. Under
he didn't say horizon.
You guys don't even agree. That's crazy.
Wait, Whitson, you didn't say horizon. We said a mountain that's 1,000 foot. If you're checking the angle to that mountain, it's not the same thing.
Does it fluctuate?
In what I'm talking about, no. What he's talking about, yes. Not the same thing.
can we actually like quantify what we're saying instead of just talking above each other?
Well, see, that's why when I said my observation, I made it clear to a mountaintop.
Yeah.
Yeah, the
well,
mountaintop
here's
will
the
change.
thing is, Sean will probably agree with me here. It does not. He doesn't think it fluctuates in the sense that you or that he understands the word fluctuate. But I'm pretty sure he agrees that it will. Your observation will change depending on some pretty observable conditions, like
absolutely.
the atmosphere.
Thank you. Welcome to Flat Earth.
Yeah. And that's what we were talking about.
See, fluctuate means go up and down.
And to explain those things, you need all the data that I was trying to tell you about, Whitson.
Okay, thank you. Okay, so my whole point was
it doesn't.
I'm so glad you guys came around.
No, because
it
like
doesn't randomly. It doesn't randomly fluctuate.
I know. It fluctuates based on atmospheric conditions. That's what I said. You guys are so behind. It's crazy. I said that 10 minutes ago. Yes, I did. It was recorded.
Yeah, you're right. It was.
Okay, so it fluctuates constantly based on atmospheric conditions. So hour to hour, day to day, it's not going to be identical. You didn't have to take an average, presupposing sphericity and a certain curvature rate.
Not what that was not.
Then you take out an average. Stop interrupting me.
I've already established that's your definition and a mean.
Sean, you're strangling the conversation here, Sean. Just monologuing and monologuing. There's no. We can't hear anybody.
So is he.
We can't hear anybody.
So is he, Chemo.
So you're a mod and you're like blah, 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 just making noise.
You're allowed to just interrupt. You're not helping. You're just interrupting.
Okay, you interrupt me every time. So whenever you look out, it'll constantly fluctuate hour to hour and day to day, just an apparent location that fluctuates based on atmospheric conditions. What you then do is you take the apparent location and try to conflate that and equate it to an actual location, right, based on an average. But it isn't an actual location. It's an apparent location that constantly fluctuates due to atmospheric conditions. Welcome to Flat Earth.
I was not talking about a horizon over the ocean. That's why I said a mountain.
Yeah, the same thing happens with the mountains. They fluctuate.
No, it doesn't.
Okay, cite it.
No, the mountain is a physical location. The mountain is a physical location. The horizon is not a physical location. It's an
welcome to Flat Earth. Yeah, so cite it.
Your observation will change on the mountain as well, but it will only change by small amounts compared to the big amounts that you get over water.
Because finally, someone answered the question like an adult.
And I said, yeah. See, maybe it's because you don't listen, but I did say, yeah, because he said he explained it, and I said, yes, absolutely, atmospheric conditions play a factor.
Okay, so it does fluctuate.
Empirically, my measurements return a fluctuation on the order of about 5 arc seconds, and the instrument's accuracy is about 1 arc second. So as long as the measurements at hand only vary a few arc seconds, yeah, that's within the range of the instrument. And when we're dealing with curvature of 26 arc seconds per mile and refraction of 4 arc seconds per mile, those little fluctuations are below the noise level.
Okay, so you have angular size change with distance, and then based on atmospheric conditions, it fluctuates the apparent location. You then pick out an average, and then you try to presuppose sphericity in a certain rate, and you try to say that it proves curvature. It's literally that dumb.
You got something wrong because when I'm measuring to a discrete point, so angular size is not at play. And I made measurements on a 4-mile increment from 1 mile all the way up to 27 miles, and the fit of 26 arc seconds per mile is very, very good, and the refracted fit of 4 arc seconds per mile is very, very good. So
yeah, that's a cool story. So it is actually fluctuating, and you agree it's just an average of an apparent location, right?
Don't dismiss it. What's it?
I'm not.
How does it logically follow that?
Yeah, cool story.
How does it logically follow that refraction exists, that the Earth is flat?
How does it? What? Are you an idiot?
How does it? Yeah. Please explain.
Yeah, I agree. You're an idiot. So we're gonna move back.
What you're implying with it is that because it fluctuates, Earth is flat, which is
no. What I'm saying is that because it fluctuates, you can't be such a dumbass that you come on Discord and pretend you isolated an actual location of curvature. That's retarded.
And you're claiming it's flat, so please explain how it proves that it's flat.
All physical measurements show a flat Earth, and that's what would happen. That's what would happen. That's what would happen over a flat Earth. And on a globe Earth, there would be a physical obstruction, an actual location, but we don't see that. We see nothing more than fluctuation of apparent locations based on atmosphere, which is what would happen on a flat Earth.
That's what would happen on a globe Earth.
You got any numbers?
So then you agree that this isn't exclusive to the globe Earth, even in your own little concession.
There would be no horizon on
Right.
the.
So therefore,
There would be
so
no
there-
horizon. All right, I'm gonna get out of here. You guys are
There'd be
just
no
don't
horizon on the flat Earth. You'd be able to
There
see
would be no
whatever.
horizon on a flat Earth. Are you
No, you
dumb?
would
no
never.
horizon on flat
Boats
Earth.
would not disappear from the bottom up on a globe.
Yes,
Earth.
they would.
The sun
Based
would
on the
not
acuity of
disappear.
it, yes, they would.
The sun would
Have
not
you ever
disappear
heard
at
of
30 arc minutes
total
big.
internal reflection?
The sun would
have.
not
I've done the
disappear
calculation,
when it's
Don. It
still
doesn't
30
work.
arc minutes big from bottom to top every day, like it does on the globe.
It
Earth.
changes.
Sorry.
It changes every day.
No, it doesn't. It goes
Yes,
the
it
same
does
day,
effectively.
same day,
I've done the
basically the
calculation.
same.
The atmosphere does not work the way you think it does. Sorry, bud.
You don't know anything. So what you think? Your
Oh,
calculation.
Yes, I do.
Yeah. How'd you do your calculations?
I did Fermat's principle.
Okay. Do you have to assume that the atmosphere is curving?
Nope.
Oh, this is Phil, the
Okay,
physics
so-
guy. He's a top boarder WITSIT.
Do you agree that the that on a plane Earth and a spherical Earth that it would be different?
Yep, and I did the calculation.
Okay, so that means that if you did the calculations to see the difference, then you had to invoke the convexity of terra firma in one of the calculations.
I did not invoke any convexity in terra firma, and prove that the atmosphere does not behave the way it should on a flat Earth.
So you strawmanned how it should. How should it behave?
According to the laws of physics.
Yeah. Okay. Well, first of all, what is the law that is supposed to identify refraction?
So the law of refraction is itself a physical law. The laws that I was referring to was the law of fluid statics plus the law of ideal gas.
Fluid statics debunks your model. Ideal gas doesn't help you either. So how should it work on a flat Earth?
The density of the air is observably decreasing with elevation.
Okay, welcome to flat Earth.
So therefore, the light rays would bend down, making the Earth look concave. Yep, laugh all you want, but that's just the way it is.
So that's your argument?
Yep, that's my argument. Game over.
So I still want
to. Does everyone here agree with this guy?
Yep.
Probably.
Wow.
What do you mean it makes the Earth look concave?
So sad, dude.
Because the light's bending down.
Got wrecked.
Now, what he's
Imagine
saying
thinking I just got
is that
wrecked.
if
Oh
the
my
Earth
God.
was flat, because we have the measured density gradient in the atmosphere, and using Fermat's principle, you can derive that it would be curving. The light would be curving in such a way that it makes the Earth look concave. But we don't see it being concaved, therefore it cannot be a flat Earth. That is what he's saying.
We see things rise to our eye level in the distance. We see all kinds of things happen where it doesn't bend down and bend around a ball. And the only way that what happens is it's very it doesn't. It doesn't. So the only thing that you can do is you can assume that when it's clear outside and we see hundreds of miles away, that actually those mountains aren't really there. It's just refracted. It just curved around the ball.
Yeah,
problem with
exactly.
it for you
Which is why
that
they fluctuate, right?
Which is why they look identical to the real mountains and they aren't distorted or inverted.
the problem is you don't see the light as it's traveling, you see the light where it hits your eye. So that's why you have to actually use your brain, not just your eyes, to understand this.
First
I know
of
that's
all,
where you're failing.
they don't even understand how the eyes work. Secondly, you don't know anything.
You don't understand.
So my glasses are just randomly produced to make me see.
No, they just understand a part. You guys don't even know science can't fully explain the eyes. You are dumbasses.
Fully explain it. Don't need to fully explain anything.
Okay, so
Just
you
have
admit
to
I was right
understand.
then. So you admit I was right 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 then.
You're going extreme in WITSIT.
So the whole room just cheered about how I was stupid, but I was actually right, correct?
You were
You
guys are consistently
Stop
dumbasses.
screaming and let people respond to you.
No, answer my question. Was I right? Yes or no?
You were screaming. Was I right? Was I right? Was I right? You are
Science
right.
cannot
completely
Understand how the eye works.
Science can't completely explain the eyes, but
We
it doesn't
don't
really matter.
understand how the eye works. That was
We
your
don't-
statement.
Yeah,
That
we
statement
don't.
is
I said we don't fully understand.
Let me address one thing you said. One thing you said, we see things rise to eye level. No, we don't. We see things above eye. We see things that are above our eye level drop below our eye level. That's what we see. Yeah.
That's crazy. So let me explain something to you. Let me explain something to you.
happen on a flat Earth.
Yeah, let me explain something to you, buddy. Yeah, because things shrink in the distance with angular size.
No,
I looked at Mount. Stop interrupting me. Interrupt me
Jake,
one more time.
why are you
I'm
asking
leaving.
a question and don't allow him to respond?
Jake, you
no
do got
size. I didn't say size. Never mentioned size. Said drop below. That's what I said.
but
So
let him, don't interrupt him. Let him get his full response.
If something shrinks in the distance, right, is it going to affect where it looks like it is relative to your eye level? Yes or no?
Yes.
Okay, so when you say it doesn't have anything to do with angular size, you sounded dumb, didn't you?
Yes, because I said
What are you
it's dropping-
talking about?
I said that it's dropping below our eye level.
Okay.
Yeah.
So
that's
what
not
we
the
do is
the claim is that it drops below eye level, not drops to eye level, which is what perspective says.
Okay.
It drops to eye level, not below eye level.
I just went and looked at mountains, and from hundreds of miles away, the mountains are down the other side of a curved Earth. They rise relatively to eye level. Now it's very difficult.
No, they don't.
Oh yes, they do. I was just in the Smoky
They're
Mountains.
well below. They're 1.5 degrees below eye level with it.
Oh yeah. How do you maintain? How do you determine eye level?
Using a theodolite.
Oh, using a theodolite is how you determine eye level.
You can just level a
Can you
tube
make-
with a. You can just level a tube on a tripod, and you can determine what's.
It's amazing. He knows no science whatsoever, but he's an expert in everything.
Hold on, Steel City. Hold on, City.
Yeah, make sure you
Hold
do an
on,
ad
Sir
hoc.
Jake.
Don't make her in the
Hold
ball.
on, Sir Jake.
You just asked how to determine eye level.
Steel, can you not hear me?
Yeah, you guys are so dumb. You don't even realize that you can't do that efficiently over hundreds of miles.
There is a
You guys
way.
are selling-
Jake's saying there is a way. Jake, what's that way?
Well, the simplest way to do it is you could just take like a copper, like a half-inch copper tube, or any straight section of tube, maybe 2-3 feet, put it on a tripod, stick a level on top of it, get that level, then sight through the tube. That's going to be your eye level.
Don't need. I posted picture.
Wow. Does everyone here agree with him?
WITSIT, they posted picture. Look at it.
Does everyone here agree with him?
Yep.
I think.
Well, thank you for showing how ignorant you guys are. So, when you look over hundreds of miles, that is not in any way an efficient way to determine.
That's a sight line perpendicular. That would be a sight line that would be perpendicular to your vertical. It's exactly what eye level means.
Hey, does angular size change with distance?
Parallel horizon.
Yes, but
What does that have to do
even
with
with
the question?
angular size, it has. If you have something that's in the center of your vision, it's going to always remain. If it's at eye level, it's going to remain at eye level no matter how far it is away. You can do this experiment in your house, or you can do it on a football field or whatever. It does not matter how far away the object is. It will always be, if it starts off centered in your eye level, it will always be at eye level. Even as it shrinks off into the distance, it will always be at eye level.
Oh yeah, what's the error range for a theodolite?
The point is the horizon is.
What's the air range, Don? That was the question.
1 arc second. I just told you.
No. What's the distance that you can?
There's no distance.
So when I go pull out the manual and it says there is, I guess it's wrong.
Go ahead, pull the manual.
You guys lie about everything.
Go ahead, pull the manual.
He gave you an answer of 1 arc second.
I said
do you understand? Yeah, but, okay. Do you not understand that an arc second is?
Do you not understand what distance is?
Do you not understand that theodolite measures angles? So the error should be in terms of the angles.
And it can only be relied upon up to a certain distance.
Depending on the size, because different sizes will have different angles of, like, the size of it will be a different angle depending on how far it is.
Okay, so the theodolite can only be depended upon for up to a certain distance.
If you have a small
what is the
object-
units of error for that? It's in
if you have-
distance, right? The error is measured in arc seconds. So you're clearly
but
wrong.
it's over a certain distance.
It's not the right units.
Yeah,
No,
you
that's
can
what they
only
tell you in
rely on them over a
24/7.
certain distance according to the
No,
manual.
so pull the manual then.
Okay, I'll find it. Just like I have to find everything
find
for
the
this room, and you
manual.
guys ignore it. Just like I went and found how you can provably take
No,
the light.
every
Listen,
time like this
I'll
with
give you an
you.
example. The whole room interrupted me, called me stupid, said I was lying. I went and got the source
No,
that proves
you're
that you
not
can take
stupid.
the
You're
light,
very
and you
smart.
can,
Pull the
and you can take
manual.
the light on the table, right? And you can reverse engineer mathematics to show how the table's curving. Now I went and forced it, and the whole room shut the hell up and doesn't have anything to say about it. So then when I go get this other thing, and you guys will shut the hell up and divert it and not have anything to say about it. You want me to keep running errands around so you can tout victory because you can't even acknowledge objectivity. You can't use a theodolite and then look over 150 miles and it presuppose it's completely accurate.
Sure.
If you want a few inches of accuracy, no, of course not. But if you need like a few 100 feet of accuracy, yeah, you'll be fine.
Why 100? Tens.
Probably, yeah,
So-
it depends on the distance. But the point is that the point is that distance is related to the error that you would like in your measurement of an object in the distance, right? If you want a few inches in error, then of course you won't be able to go hundreds of miles because the error of the angle is in the arc seconds.
The problem here is we're not trying to figure out the distance to something. We're trying to find the degree level of eye level. Now, the answer to that is an angle. So the answer of the error
You
rate
think
will
that's
also
the
be
problem
an
here?
angle, not a distance. No, the problem is WITSIT doesn't understand the difference
Exactly.
between
What's
distance
a
and
moron?
angles.
That's the main problem here. He's like a fucking lunatic.
I'm just like,
hey, dude, shut up! You're interrupting. You
Or what,
fucktard.
bitch?
Dude,
what?
shut the fuck up. The
You're
problem
just
here is
throwing
that
around ad homs.
WITSIT is a fucking moron.
I'm just gonna talk
He's
through you
not
as you ad
talking.
hom
Can
me.
you shut the fuck up?
We'll say something with substantive specificity.
I
instead of
don't
ad
need to
hom.
listen to you. Shut the fuck up. I'm gonna local mute you right now. So WITSIT is just holding this fucking room for like how much now? An hour and a half. He says absolutely nothing. He says absolute fucking nonsense. And this is allowed for some reason. It's all
See, he has
fine.
nothing to say. He has nothing of substance to say because he's an idiot.
So if I measure the angle down to the horizon to be 1.5 degrees, why would distance matter?
Why would this?
The error
accuracy
is
disproportionate
to
to
the
How much-
arc seconds, right?
How much?
So
how
the
much
error
is
is in the angle.
How much is an arc second over 150 miles? What's the error? In feet.
That you tell me.
Do you not know how to calculate this, WITSIT?
I'm not calculating anything.
What do you think
know-
you can calculate, dude? Serious.
I know for a fact that theodolites say that to maintain most optimal accuracy, it's like less than 150 meters. You guys will bring up
What
the
do you
theodolite
even know
talking about
what an arc
200
second
miles.
is?
You guys will
What's it-
bring
do you
up
know what an arc
theodolite.
second
Hey,
is?
shut the fuck
Guys
up
will
while
bring
I'm
up
talking,
wow.
dude. Why do you guys constantly think you can interrupt me?
Because you do the same to us.
No, I don't. I let someone finish, then I go to respond, then five.
You didn't let me finish. You
Alright,
fucking
peace
tried
out,
to
peace
get in
out.
every 5 seconds.
The basic premise though is like Mount Everest was done at over 100 miles and they got a few feet of accuracy. I don't see. It really depends on your error tolerance.
Well,
And
the
if the
problem is he
curvature of the
doesn't-
Earth exceeds that error tolerance, then it's a fine measurement.
He doesn't understand that we're measuring an angle, so the error will be an angle. An error in the angle, not an error in the distance. We're not measuring a distance. We're measuring an angle. Like,
Yeah, we're not
I don't see why this
measuring
is so hard to him.
We're not measuring any kind of length at all. So this is pointless.
Yeah, Polaris is not too far away. We can do Polaris to an arc second. Yeah, it has nothing to do with the distance to the target. It has to do with the discrete size of the target. And when I measure to a light on top of a radio tower at 25 miles away, it's a discrete point. So angular size doesn't even mean anything. It's a point in space. And when I have 1,600 feet of elevation change, yeah, 1 or 2 feet of error is stunning.
I think WITSIT is gone.
Yeah, he left.
Yeah, they just want to. That
He
whole
couldn't
thing.
take enough of him not being able to show
He
that
just-
he doesn't understand things.
Yeah, he just says stuff and then thinks that he's correct, and it's just not true.
Okay, now the whole thing with the short distance of theodolites, like a couple miles, is electronic theodolites that have laser rangers built in. They quote the specification of the laser ranger's range, but its angular output has nothing to do with that range. So that's where the convolution comes up. It goes, oh, this has a 5 mile range. That doesn't mean the angles can only be measured to targets 5 miles away. That just means the distance by laser range can only be measured 5 miles away. And when you measure angles to Polaris or distant radio towers or distant mountains, yeah, you've got 2 or 3 seconds of standard deviation, and you repeat the measurement 15 times, you get a standard error of about 1 or 2 arc seconds. Over, say, a 20-mile distance, yeah, you've got like a foot of uncertainty. And you do that on multiple days, yeah, guess what? you'll be 3 or 4 seconds different. In other words, yeah, a couple of 2-3 feet different. And you do that over a month, and yeah, you average that. That doesn't mean that it all goes to shit and bogus. It means you have a standard error, a standard deviation, and an uncertainty of 1,600 feet elevation change, give or take a couple feet. And if that give or take a couple feet is what WITSIT just says, oh, now you're just faking shit and making shit up. And when he said that if he could make measurements on a flat table that could be turned into curve just by math, I go, no, not with accurate
Dude, you can stop analyzing his fucking shit. He's gone.
That was the claim. Remember when he was going to prove that right or wrong? That he never did that.
No, he's not going to prove anything. He just says that it's an average, and therefore you can dismiss it.
Maybe he's looking for the manual.
It's like his argument of because the where you see things on the horizon fluctuates, the Earth is flat. It's a complete non sequitur, but yet he will claim it over and over and over again.
Not to mention, we know how the atmosphere behaves, so we can know how the light bends, and it just does not bend in a way to make a flat Earth look the way it does in reality.
I think WITSIT has a somewhat valid point in that we don't seem to address his information, but I think the problem is that he usually argues so long about putting his information in that nobody's looking for it at the time he does. He just sort of drops it in silently.
So what he does is the Mott and Bailey trick. So he'll ask a question which has a broad answer, which kind of agrees with his point, and then claim victory, right? When that's just not how you make an appropriate argument. Like, for example, the thing with do things get smaller in the horizon?
Well, you kept engaging with him after he did that, so why are you telling us?
No, I'm just pointing it out. Like, this is I didn't engage with him after that, but you have to make him like. You can't answer a dumb question like that because it's exactly where he's going. He's going to say, "See, things get smaller, therefore things can drop below your eye level," and that's just not true. Chaik was trying to make a point that distance, observations of things in the distance drop below your eye level. This is not consistent with perspective. This is consistent with curvature.
WITSIT is the ultimate shapeshifter. If you get him in one spot, he'll just shape-shift and go and tack differently. Then he'll get into areas that are either not well understood or difficult to define, like he loves quantum. He loves, Einsteinian
dark matter.
Or then he'll do like the argument he did earlier, where it's like, do we completely understand how the eye works? No, therefore you're wrong. Like, no.
Therefore, we don't know how the eye works at all, right? And that's not true.
We know some aspects of the eye very well.
We know about optics. We know optics really well. I bet he wears glasses. I know Lemonbird wears glasses, and Lemonbird doesn't understand optics for shit.
Never mind optics. They take half-blind people and make them see again.
Yeah.